This fourth lecture on interpolation. Today we shall discuss the algorithm for the interpolation formulae that we have discussed in the previous lecture. To start with, we consider the Newton's forward difference formula, forward interpolation formula, provided n plus 1 say pairs of xy value. We can at most choose a polynomial of degree n, and as per Newton's forward formula, the final result is this, where you recall that p is defined as x minus x0 by h. So to implement this the corresponding algorithm, we shall first define two subfunction or subprogram, one to calculate the combination symbol and other one to calculate this for ith forward difference of y0. So we shall first define this or chalk out these subprograms, and then we shall use this subprogram for the calculation of the main program. So we start with the algorithm. As you are all aware of the fact that algorithm is the systematic steps of a program that has to be executed. In algorithm, it is preferred that no signature of specific programming language should be there. That is, it should be independent of the programming language that you would be using. It should not be specific for Python or C or Fortran. The algorithm should be one which could be implemented using any language. So we first going to define this chalk out this subprogram. Before going to this, I would like to mention that the word algorithm has been originated from the name of ancient mathematician of Iraq, Al-Ghurair, who is famous for his work on Indian mathematics. Now, first thing is program. I give it the name. The inputs are P, I, output is COM. So the inputs are P, I, output is COM. First thing, since it is a product form, this is in the product form, we must initialize COM, the final result, to 1.0, the additive identity. Then we start a loop for j in the range 1 to I. For each value of j, we define now at the first step j is 1, so it is p by 1. In the second step j is 2, so this is p minus 1 by 2. So the part is being calculated easily. End of j loop. Then the program return COM. End of the subprogram. So this is a very simple subprogram, and then come to the subprogram subprogram forward difference. Before going to specifying the arguments, it is the forward difference formula, so it requires the value of I, the ith forward difference to be calculated, and you require the set of y values. So our inputs are yi and the output is forward difference. This performs a sum, so we initialize sum to 0 or forward difference to 0. This is the additive identity, this was the multiplicative identity. Then we start a loop for j. J in the range 0 to I. This is the loop j. For each value of j, we first need to calculate this one. So we call CC. Then FD is equal to forward difference is equal to FD plus minus 1 to the power j star CC star the value of y at I minus j then end of loop end of subprogram. So this is the simple way of implementing forward difference. If we were to calculate the forward difference of y5 or ym, then another quantity m has to be introduced over here, and this m has to be added over there. Now coming to the main program. So we have already chalked out the algorithms or programming part which could calculate this and this. Main program. First step. Define arrays for set of xi and set of yi values. Then we need to inputs number of data in set of xi and yi data for I in the range 0 to n and the value x, the value of x at which interpolation has to be done. Then we calculate h. First we calculate h is equal to x1 minus x0. Then we calculate p, x minus x0 by h is p. Then we are to initialize sum to 0. Then we will start a loop. For each value of I, we first call COMB. P is known, I is known, this is CC combination. This may be same name, no, there will be no conflict, then we call forward difference. I set of yi values and the output is forward difference. In scientific programming techniques, there are techniques for transferring all these data from here to there and there wherever required. In that case, yi may not be included in the program, because once we define yi, there is a common block facility that every data that are being defined here and are specified to be shared otherwise can be shared between programs and subprograms. In that case, you need not to include y with as argument, rather than we can share the y and y values between main programs and the relevant subprograms. Then the sum is redefined as sum plus this part is CC and this part is FD. End of I loop. Result is end of program. So this is the algorithm for implementing for Newton's forward difference formula. Here I have deliberately used the subprogram technique so that the moderation within a particular part gets as simplified as possible. Here we first have calculated the combination symbol in this subprogram, then forward difference in this subprogram, and we have just in the main program we have just considered the program for calculating the sum or product of two things. Now we come to Lagrange's interpolation formula. Recall that in this case phi n of x is equal to summation over I is equal to 0 to n yi, then product j is equal to 0 to n excluding I, x minus xj by xi minus xj. This is the formula. So algorithm for this is very simple. Arrays for xi and yi, then inputs n xi yi values, I ranging from 0 to n, and x value at which we use the interpolation. or we perform the interpolation. Then first thing is initialize sum to 0. Sum to 0. Then we start a loop for I. Loop for I is equal to 0 to n. Within this loop, we have to calculate this product. So then we initialize product to 1.0, the additive identity. Then if I or j not equal to I, j not equal to I, then we calculate product is equal to x minus xj divided by xi xj. End of j loop. So this part, by this we have calculated this much. End of j loop. Then we come to implementation of this part. Sum is equal to sum plus yi times product. End of I loop. Result is sum. End of program. This is the simple algorithm for implementation of Lagrange's interpolation formula. That's all for interpolation formula. From the next class we shall discuss numerical integration.